Okay, welcome to our new setup. We are going to cover a new topic today. So to summarize what we've done in the past, we have learned the mechanics of programming. We have done arithmetic and algebra with numbers, strings, booleans, and images. Uh, but how do we use them to make stuff, right? They don't really teach you this in school. How do we go from a blank page with a problem to our problem solved? So how do we go from blank page and problem to problem solved? So that's the topic of today's session, and this is what we'll be doing for the next few sessions, actually. So this first part is just me going to be explaining stuff, and then I'll ask you to write some code as well. But first, I'm just going to explain some stuff.
Okay.
So we are now going to return to the idea of information and data. This is the foundations for everything we'll do. Remember, like when we say like 5 degrees Celsius versus just the number five, right?
Yeah.
5 degrees Celsius, we as humans, we understand that to be temperature, but the computer will only see five.
Yeah.
So this is the foundation of what we'll be doing. And this idea of understanding the relationship between information and data, we are going to formalize that relationship in our programming by doing a data definition. A data definition. So data definition, this establishes the relation, a specific relationship between some piece of information and how that's represented in the programming language. Okay.
Yeah.
So, for example, let's say uh, we want to create a data definition for temperature Celsius. Okay. Let's say we want to do that. This is a very simple example, and as we move forward, we'll create much more complex things, but for now, let's keep it simple. We just want to have Celsius. The first thing we want to do is we want to write down the representation of the information. So for the case of temperature or Celsius, what's a good representation of the information?
You will want to define a variable for that. You represent it as a number.
A number. Okay, that's what I'm looking for. Yeah. So we choose to represent temperature as a number. So first, we say that we choose to represent temperature as a number. Okay. So that's the first thing you want to do. But here's the thing. We want to formalize this idea of temperature. I'm going to capitalize the T, temperature. Okay.
Yeah.
Why am I capitalizing it? Because this is a special vocabulary, a special concept in our program. We are formalizing it. Okay. In fact, I'm going to call it Celsius. I changed my mind. I'm calling it Celsius instead. Okay.
Okay.
Now, the next thing, I feel like this is a bit long, so I'm going to do this instead. Celsius is a number, a lot shorter. Okay. Generally speaking, uh, I'll ask you to like write it like this. Uh, Name of data definition is net representation. Make sense?
Yeah.
Okay. So that's the first thing. The next step is I want you to write down the interpretation of the data. So what does it mean to a human being? So for Celsius, we will say this represents the temperature in degree Celsius. So far, so good?
Yeah.
Okay. Um, the next step is we want to provide some examples as code of the data definition. Okay, so provide some examples. So here now we use variables. Okay. So uh, for example, Celsius, let's say like 20. For 20 degrees Celsius, I'll write this. What are some interesting examples of Celsius?
The most common one, you can use the room temperature,
What is that?
which is 25 degrees Celsius.
Okay, 25. So we can leave a comment, so like room temperature. Okay, what other interesting examples of Celsius are there?
The freezing point of water, which would be 0 degrees, ice.
Okay, so I could put that first, 0 degrees. Okay, what other
The boiling
examples?
point.
And what is boiling?
Boiling point of water will be 100 degrees Celsius.
Zero. Okay, cool. So I'm going to add some other things here. For example, we could do also negative numbers. So for example, -3. We can also do decimals. For example, let's say 4.7, right? So when dealing with numbers, try to have variety. Have numbers that are not divisible by 5 and negative numbers. Zero is one of the most interesting numbers because like in civilization, it's been said that zero is like not invented first, it's actually invented last, or at least much later compared to the other numbers. You cannot divide by zero, so zero is very cool. You can also have decimals. Okay, I'll leave it at this for now. So these three steps here, we call this the design recipe for data definitions. When we say of design, design just means going from A to B systematically. Okay? And recipe is a series of instructions to follow. Just like cooking. When we're cooking a meal, we follow a recipe, we just follow the instructions. Okay? So this sounds very simple, but I can assure you it's very important. Um, and it doesn't have to be Celsius also, we can also do like Fahrenheit. Fahrenheit is a number. Uh, and we can say what it represents. So this is step two, the, the temperature in degree Fahrenheit. We can also do some examples. So the freezing temperature is not zero, it was going to be 32. Um, room temperature, I don't even know what room temperature is. Zero is still a valid example. It's just not going to be freezing temperature. Right. And we can keep doing this. So this is for simple, the simplest possible data definition. Now we're going to move on to functions. How do we write functions systematically? So now design recipe for functions. I'm at the end of the file now, line 84. So for functions, it's very similar, but a little bit interesting. First, we want to write the signature of the function. And a signature, remember, a function is just inputs to outputs, right? So you have to specify inputs to outputs in terms of types. So here's a demo designing a function that converts Celsius to Fahrenheit. Okay. So what is the signature of this function? Actually, yeah, let me ask you, what's the signature of this function that converts Celsius to Fahrenheit?
Um,
Sorry, was that?
The signature will be, is it a formula or something?
Oh, what's the input of the function?
Or the input will be, let me see the input will be in, the numbers will be in Celsius.
So I'm going to write Celsius. So this Celsius here, capital C Celsius, this line 91 Celsius is referring to the Celsius from line 56. We're using the vocabulary that we have built just now. Okay.
Yeah.
And what does it produce? What does this function produce?
It takes in the numbers, the temperatures in,
Okay.
is an input, right? So it takes in numbers.
So I notice how I don't write number, I write Celsius. Do you see that?
Yeah. So it takes in the temperature.
Yeah. Uh, but I write Celsius on line 91 because I want to refer to the Celsius that we've defined in line 56. Does that make sense?
Yeah.
Okay, so it takes in Celsius. What does it produce?
I would say it produces a number.
A number. Is there a data definition that's more specific to what it produces?
Um,
What does this number represent? What, what's the interpretation of this number?
or the number is temperature.
Okay, and what's the name of this temperature?
I think it's the Celsius.
That's what it takes in, but what does it produce?
Or the it produces the, it will be the temperature in Fahrenheit then.
Okay, Fahrenheit. Okay, so this Fahrenheit on line 91 is referring to the Fahrenheit on line 67.
Yes.
You get me?
Yeah.
Okay, we'll move forward for now. This will become clear later. So let's say that's the signature of our function. It takes in Celsius and produces Fahrenheit. The next thing, after we write the signature, the second step of the design recipe is we write the purpose statement of the function. Okay? What does the function compute? So we write this as a comment, as a description. We say that uh, converts the given temperature in Celsius to Fahrenheit. Okay? You following me so far?
Yeah, that's good.
Okay, so we write a description of for what our function is doing. It's converting Celsius to Fahrenheit. The next step of the design recipe for functions is examples/tests. Um, so what I'm going to do here is I'm going to write Celsius to Fahrenheit. So I'm going to define the outlines of the function, but I'm not going to fill it in yet. I want to write the test first. So Celsius to Fahrenheit. And I'm going to reuse the examples that we have written just now. So for example, C0 is Fahrenheit of 32, right? And we can use our other examples as well. Celsius to Fahrenheit. C -3 is, I don't actually know.
What's the, anyway,
I'm going to cheat a little bit. So in our test cases, we can just write raw computations. I'm just going to do that.
I think it's supposed to be 9/5 instead.
Sorry, what?
I think it's 9 divided by 5 instead of 5 divided by 9, I think.
Oh, yes. Wait a minute. Yeah. Cause sorry, when I give this example, I usually start in Fahrenheit. I wrote the formula for Fahrenheit to Celsius. I think that's one other mistake I did. Whoops. It's times 9/5 plus 32. is inverted. Sorry. Yeah. I did it the other way around.
Yeah, that's fine now, I think.
Okay. And then we can have 4.7, 9 over 5 times 4.7. So notice how I'm using a variety of numbers. I have zero, I have a negative number, I have a positive decimal. You see that?
Yeah.
Good mix and match. Next, after example says test, we write the body of the function. So it appears here that from lines 100 and 101, we can sort of see that that's basically the answer, but we have to generalize the specific value we're plugging into the parameter c. Okay? Now if we run this, oh, what the? What is happening here?
It says C100.
Why is it repeated twice? Um, I, okay, I don't know what happened. Okay, wait, give me 1 second. Let me fix this. Okay, for some reason things were repeated twice. Is that, hope it's fixed now. Okay, now if we run it, it works. Okay.
Maybe because you were sharing on my screen as well. Is that it?
Yeah, maybe, I don't know. Anyway,
That's okay.
so to summarize, I've taught you the design recipe, which is a series of steps you can follow to systematically solve a problem. Okay. This, does this seem straightforward?
Yeah, I think it makes it it's straight. It looks, yeah.
Okay. Now, I'm gonna give you the mic very soon, but I'm gonna introduce a new idea. So, a data definition can take on many forms. We just saw an example of a data definition where we represent a piece of information with a primitive data type. So we just represented a piece of information with a primitive data type. Uh, However, a primitive data type is very limiting. There's only so much we can represent with them. Okay? So we're going to now introduce a new way of representing information where the information is one of many choices. So here's the new situation. We are writing the code for a traffic light for traffic lights. Okay, we're writing code for traffic lights. We want to represent which of the three lights is currently on in a traffic light. Okay, so far so good.
Yeah, so good. Yeah, so far so good.
So this is new. I'm gonna show you something new. So I'm gonna first remember this formula. A name of data definition is representation. Remember this?
Yes, I remember that. That's the signature, isn't
Yes, signature
it?
somewhat, but for the data definition.
Yeah, data definition. Yeah.
Okay. Um, the name of the data definition, I'm gonna name this traffic light. Okay. For representation, this is new. You're not gonna have seen this before. The representation, I'm gonna say is one of red, yellow, and green. You see that? So we call this enumeration, where I don't want to say data representation, where the data is one of many finite values. Make sense?
That does make sense. Yeah.
Okay, so I did the first step for you. What's the second step of the design recipe?
We have to, the second step would be to come out with a the interpretation of the
Interpretation. Okay,
data.
what's the interpretation of this?
My interpretation in this sense would be since there are three options, it's like conditional also.
No, but yeah, but what does this, how would you explain this to a 5-year-old, this traffic light?
Yeah, I would say red for the traffic lights in the red means you stop.
Okay.
The yellow means you should you with yellow means you should prepare to stop,
Yep.
and then green means you should go.
Yep. Okay, let's write this down. Can you write this down on line 77?
In the form of a comment, is it? Should it be a comment?
Yes, yes. Can you write it down as a comment?
Okay. Maybe like for the car, it respects to the cars, right? Or just gonna stop.
Okay, very good. So this is the explanation for the human being, the interpretation of the data. All right. Next, what's the next step of the design recipe?
That would be to we should give a test.
Uh, for data definitions, we don't say tests, we say examples.
Okay, examples. Yeah.
Yes. So can we write some examples of traffic lights?
Would it be because for me, I think this one it just looks like the example itself.
Can you show me?
No, I so be examples of traffic light, is it?
Examples of values of traffic light, right? Like when we wrote examples of Celsius, we had 0, 20, 25. These are values. What are examples of values for traffic light here in our case?
Okay, we will still be using the examples will be red, yellow, and green, I think.
Okay, can you show me?
I would say, I can say, oh, sorry. Okay, I'll say red, say red is stop.
Okay, let's pause on red for a second. So line 81, red equals stop. What is stop?
Stop here in this sense means that the car should stop
Okay, but
at the light.
right now it's a variable, right? This variable is not defined.
Okay. Yeah, so it's a string.
So we gotta put in a string.
Yeah.
Okay. But this is not quite right either. If you look at line 73, a traffic light is one of red, yellow, or green. It can only be one of the three strings we have listed. Is stop one of the three strings we have listed?
We listed red, yellow, and green.
Yep. So a traffic light is only one of those three strings. Anything else is not a traffic light.
Okay. Okay, so I can use, I would say instead of these, I will represent it as maybe, um, in terms of color. Right? So color one means red.
Okay, nice. Okay, the line 82, the yellow is missing one L.
Oh,
Okay, very good. Okay, so I'm gonna share a different screen for a second. Let me pull. I'm gonna draw something. Let me pull that up. Okay, so currently I'm showing a whiteboard. Can you see it?
yes, I can see it.
Okay, but not. This is for another student. Okay, so this imagine we have the universe. So let's say this box is our universe. Are you familiar with set theory in mathematics?
Yes.
Okay, so I think this should sound familiar to you. In our universe, we have a lot of elements. This is our universe of data, by the way. Let me write this down. Universe of data. This box contains all the data that we could possibly describe. So, for example, there's an element for 1, 2, 3. There's 2.5. Okay, right. So these are all the numbers. We have string hello. We have string. We have an empty string here, right? And then we have true, and we have false. A data definition. What a data definition is drawing boundaries between, is drawing a circle, it's making a subset of data. Okay?
Yeah.
So for example, this is like the Boolean subset. I draw the A inside actually. Whenever you make a data definition, what you're also saying, what you're saying what is a Boolean, and you're also saying what isn't a Boolean. So for example, the A complement, right? True and false are Booleans, nothing else is a Boolean. Okay?
Yeah.
Um, so like imagine we have a lot more numbers. Like let's say like these are all the numbers. Let's say theoretically this subset contains all numbers. We might call this all the numbers n. Oh, I'm gonna say R, subset R, like in mathematics. Sorry for my handwriting. If we imagine that all the numbers are in here, yes, this subset is infinitely big, but it's still a set. Here we have strings. I'm gonna say S for string. But here's the thing, when we say string, right, there's so many strings. We got like world, but there's only three that we care about here. Red, yellow, and green. So there's a set, there's a string set that contains all possible strings, the theoretical set, right? S. But what we're doing, we're only saying only these three strings is a traffic light. You see that?
Yeah.
We are drawing a circle around the data that we care about. In our case, red, yellow, or green. Right? Make sense so far?
Yeah, it makes sense. Yeah.
Okay, yeah. So programming is, it uses some ideas from mathematics. In fact, the origins of computer science could be understood to be from mathematics. Okay, this Zoom session is about to expire, so I'm going to close this one and send you a new link on Gmail, okay?
Perfect.
All right, I'll see you in a minute. All right. Um, so yeah, when we wrote traffic light, we drew a circle around red, yellow, and green. So a traffic light is only one of red, yellow, green. There's a convention we want to follow. Lines 81 to 83. Can we capitalize the word color? Hello?
Sorry, do I need to share the live share link again?
Oh, no, no, I'm still on it.
Okay.
All right. Lines 81 to 83. We have a convention. Whenever we have a variable that doesn't change, we capitalize all the letters. So can we capitalize color from lines 81 to 83? Yeah, so this is the convention. We're telling other people this is something that doesn't change. Yeah. Okay, very good. So for now, we have completed the design recipe for data definitions. We are now going to move on to the function. So I'm going to give you a task. Design a function, rotate traffic light that consumes a traffic light and changes the light from red to green, yellow to red, green to yellow. All right. What's the first step of the design recipe for functions?
We have to give it a name.
Sorry, what's that?
we have to give the function a name.
Sure. Okay.
So I'll call it yeah, it's a traffic light. Yeah.
Okay. What's next?
Next thing we have to write a test.
Okay. There are two things we have to do before running tests. Do you remember? Let's scroll up to the design recipe for functions. What's step one?
Oh, you have to give the signature of the function. That's the
Okay.
input to the output.
Okay. So what's the input to this function?
And the input for this function is, it will be we have three inputs and three outputs.
Wait, you're saying that what are the three inputs?
Yeah, it'll be red, yellow, and green.
Oh, wait, red, yellow, and green. So all three lights at once?
Oh no. Oh, sorry. Okay, the input will be we have one input and one output.
Okay, what's the input and what's the output?
It's either of red, yellow, or green.
Okay, what's the name of this set? What's the name of our data definition for red, yellow, or green?
Oh, it's a string, I think.
Let's now
So,
look at line 73. We gave this data definition a name.
oh, we gave it a traffic light.
Traffic light, yes. So it takes in a traffic light. Can we write that down as a comment?
So it should be uh, this is the design here recipe. So we can see that the name, the input, let me check in. Yeah, so the input will be traffic light, right?
Okay.
Okay. And output will be a bit tricky. So the output in terms of types, in this sense, it will still be traffic lights, isn't it?
Yeah. Nice. Great. Yeah, what's the next step of the design recipe?
Yeah, the next step would be to give a purpose statement. That's
Okay,
what the function does or compute.
very nice.
So what the function does is what I'm trying to define here, which is fun, um, the traffic light. So you should take in the parameter called traffic light, right?
Okay.
Let's see. Sense?
Okay, so the purpose statement is a description. So there should be a description for what this function does. For example, line 57 for Celsius to Fahrenheit.
Oh yeah, I'll say the function converts in
Sure. Okay. All right, what's next in the design recipe?
we have to write the text. So we define the function and then we write the test.
Tests. Excellent.
Mm. So it should, okay, the yellow, the person will say red.
Great. Okay, I'll explain this in a moment, but I would like you to use the examples we defined from lines 81 to 83.
All right, so we'll just be so here so okay, so I'll be using the color one. So yellow, green is color three.
Yep.
Okay. And yellow is color two. It's color one. That's done.
Great. What's next?
Next is to write the function body.
Excellent. Okay, let's do that.
Um, let me see what I'm going to, if,
Hello?
so yeah. So for the function body, we're looking at um
So we're looking at the function body, right? And you say if. Why do you say if?
yep, we have three options here.
Okay,
So
so
the
we know
first one,
traffic. Yeah.
if the traffic light is red,
Okay, how do we write that down?
if statement is it the same as this? Okay.
Yep.
Yeah, I'll just say if because
Okay.
if color one is red, that is if it's true, right?
Okay, how do we say if traffic light is color one? How do we say that?
Can you actually specify if can you use this here?
Yes, that's fine.
My question is, do I need to actually specify like this again?
Um, well, color
No.
one's already red, right? But when you
Yeah.
told me this just now, you're saying it's a traffic light color one, right? So what should the second part be here? What are we checking to be color one?
We are checking if color one is red. But
Is
if
that what we're
it's
checking?
oh, we are checking that if it's true
What are we checking to be true?
that the traffic light is red.
That the traffic light is red. So traffic light, right? The parameter.
Oh, yeah, yeah, yeah.
Okay, so let's write traffic light.
It's- see. Oh,
Okay, we are out of time. I think we made good progress today. If you're able to, I recommend trying to finish this at your own time. If not, that's okay too. We'll pick this back up the next time we meet. All right?
okay. Yeah.
Okay.
I,
Yeah, no, we covered a lot of ground today. Uh, Let your brain rest, and we'll pick it back up next time. All right.
perfect.
Bye bye now.